Hello?
I think it's for the camera for recording. So
Oh, so it's fine, right?
yeah, yeah, don't worry.
It's not the micro.
It's a no.
Okay, fine. Yeah, so thank you for your introduction. And today my topic is perceptual quality assessment of the AI generated, actually it's AI-driven content. So it contains many about the AI enhanced and also the AI generated content. So maybe the first is a brief introduction of myself. So currently I'm working on mostly the multimedia signal processing and also multimodal learning. And actually from the Asia and also the North America, and also currently I'm based in UK. And also I've been into several companies like the Microsoft and also Alibaba to work on some like mostly the image processing and computer vision problems. So first is what's the problem, right? So we have what is the multimodal perceptual intelligence? So for our human, we have these five senses. And for those machines, they usually have these sensors to detect and to acquire some information. While our human brain and also the machine system need to recognize and also process those information. So nowadays we have the most important is the multimodal visual content. So for example, from this traditional, that's about the 2D images and the videos. So mostly it's the planned information. And from this to this stereoscopic, like the 3D information, always you have the left and right views. And then we got more immersive, the light fields that got multiple of the views. And nowadays we also have the VR. Here is one of the VR formats, that's 360-degree images. And then we have the point cloud and like the meshes or other 3D content. And most recently, we got AI-generated content, like those examples. So all these different multimodal visual content, we got different characteristics and how to, based on their perceptual characteristics, how can we develop different models to evaluate those content. And I think another important factor here is the perceptual distortion. So except for the content itself, so we got a different distortion type. So on the top left is the traditional compression distortion. So I think most of you are expert in this compression or artifact. So from the left to the right, you got more compression distortion. And also the bottom left and the right one is just the AI enhanced and AI generated content. For the bottom left is one of these super resolution content. So you got an input of the low resolution image and you use different algorithms to generate or to super resolve those image. So you can see that different content, the different algorithm actually they generate very different results, right? So some of them look blurry while some of them look very sharp. And the right one is for AI generated content. So if you compared with the top one is the traditional content, that is the blurry image, and the bottom is you input like a prompt to let the AI models to generate some content. So mostly compared to the traditional case, it's we need to consider, like the previous speaker said, that we need to consider different dimensions except for the traditional visual quality, but also the authenticity and also the consistency between this generated content and the input text prompt. So all this is different distortion type and different content that we need to consider in our model development. So our motivation here is the rapid development of this AI-driven content. So those include the, I think it's AI enhanced is just partially generates the content, right? But AI generated is you need to generate the whole image or whole visual content. And also the traditional metrics like the PSNR, SSM, UMV math, they fail to capture such like the perceptual consistency or alignment and also this authenticity aspects. So nowadays we have different video platforms like the YouTube or Instagram or other things. So they need this reliable perceptual evaluation for this quality control or user trust, and even they want to ensure the content authenticity. So on the bottom, I just show you one example that you can see it's a true 4K image that's captured by the real camera. And the right one is just the fake super results generated by some algorithms. So how can we use how can we develop like a better model to detect those different true or fake 4K and how to evaluate those quality is a very important problem nowadays. So for my talk, it's just 3 aspects here. So the first is I want to talk about the compared to traditional content, how is the multi-dimensional quality of the AI-generated content. And next, I want to go into the AI-based enhancement. So those include 2 topics. One is how to evaluate those AI-based enhancement and how to develop some models to actually optimize those enhancements. And finally is how it's very important for industry, I guess. Even nowadays, we got more and more AI-generated content and enhanced media. Even I talked to some industry guys, they told me that you have users usually have AI-generated content, and then they upload into the platform. And then the platform got to enhance this content again. So it's got 2 processes. So first one is generated and then enhanced. So how can we develop an algorithm to evaluate its authenticity is very important now. So for this user trust, I guess. Okay, so the first model that we consider actually is the first model. If you look at the literature, that is to evaluate AI-generated content from the multi-dimensional aspect. So you can see those examples. So the above is 2 images, traditional nature images. So one is blurry, and the other is something like the underexplosion. So they got very dark environment. So the below that is 2 AI-generated content. So except for this visual quality, we need to consider about this authenticity and something like the consistency between the generated content and input text prompt. So to tackle this problem, we proposed, we call this AFF block, is actually to fuse the multi-scale features and to capture these different ways and to use this to fuse with the, so AFF is for this image content and how to fuse with the text features and to evaluate its consistency is is a main problem here. I think it's mostly very straightforward because it's first model that if you input an image and also a text prompt, and we use a clip or other models, foundation models, you can extract some features. And we developed such multi-scale block and also compared with the text to get the similarity. So for this green block, we calculate the cosine similarity to evaluate its consistency. And for other dimensions, we use MLP to output its quality dimension. And for those, we actually optimize them together to got the final 3-dimensional output. So we use the 3 different databases. So the first two is the text-to-image generation, and the third one is image-to-image generation. So you can see some examples below these tables. And we calculate, actually for the first database, they only got the traditional perceptual quality and also the consistency. And for the second database, they have the 3-dimensional, except for the quality and also consistency and authenticity. And we compared with the different dimensions and also the average performance. And this one is the third database, and it's also, I mean, if you compare with the first 2 databases, you can find that the image-to-image generation is even more complex because all these algorithms, they got not very high performance. And finally, we have this scatter plot to evaluate how our prediction is consistent with the ground truth. So it's the first algorithm that we consider about the multidimensional quality aspects of the AI-generated content. And the second one is that we also want to propose actually we are considering that 3 dimensions. Is there any relationship between these 3 dimensions? So we consider how to use the one of them dimension to help to assess the other dimension. So that is the second work that we propose this clip-based, actually it's the first clip-based blind quality models for this AI-generated content. So when we search for the literature, we find that only the one in IIII 2023 is the model based on clip for traditional nature images, but we are the first to evaluate the AI-generated content. So our main idea is to use this visual language consistency to guide this multimodal prompt learning. That means we have So our motivation here is we compared the perceptual quality, this dimension, with the alignment that's consistent dimension. We find that this actually have a good correlation with each other. And now this one of my students is also compared with the other dimension. Except for this perceptual quality and alignment, we also got this authenticity. So it's 3 dimensions. So actually they have different, all have the correlation with each other based on our analysis. So the model here is to use this alignment quality dimension to help with this perceptual quality prediction. So we have the two, one main task is to predict the perceptual quality of this image. And the other task is to use the alignment, the consistency dimension to help the main task. So the idea is very straightforward. And nowadays we are working on the 3 dimensions and how to propose a model to actually to bridge them together with one model. And I only use this quite straightforward to give you a demo here. We pick up different AI models and to give the AI models the user prompt and let different IQA models to have the quality rankings. And you can see that finally our model is more, I think maybe it's most important for the high quality range that it can keep consistency with the ground truth. So the first part I want to mention is about the multi-dimensional aspects of the AI-generated content. Next is, you know that the AI-generated content, they are fully generated by the text prompt. But now it's another AI-driven content is enhanced by some processing algorithms like the superillusion or other restoration algorithm. So how to evaluate those AI-based enhancement and how to optimize actually is also a very important problem. So what I want to emphasize is that in real world, we got this multimedia processing chain, right? It's not only one stage. You got something like you have the noise distortion or blue distortion. You got one stage. But actually in real world, we have multiple distortions. You got pristine quality image and you have different distortion, like a distortion chain. And finally, you get the destination image. So how these different stages can influence each other, or how different distortions they are, what's the relationship between them. So here we propose actually is very initial work. We propose a data set that is consider different, like you can see that we compress these videos or images. We use different bit rates and simultaneously we consider different sharpening and also the smoothing parameters. That means you can have the different sharp and also the smooth processed based on the existing images. So that means that we want to emphasize the different processing stages of these images. And most importantly, that we want to focus on is one of the distortion is AI enhanced is for the superillusion. So actually, I worked on this superillusion quality assessment from my PhD degree and then my postdoc. I also proposed a lot of like metrics, and this work are conducted by my students nowadays. So we find that in the literature, if you want to optimize the superillusion, the final goal is to optimize the algorithm, that you need a full reference metric. It's not a blind metric, because blind assessment metric will cannot keep this. Firstly, they cannot keep the fidelity. Maybe they cannot learn the content of the original image. So that's we search from literature. We cannot find any of the deep learning based superillusion full reference metric. There is no superillusion based full reference metric. So we want to propose another full reference metric and use it to guide this superillusion algorithm to help select and optimize those superillusion algorithms. So what our motivation here is that you can see that you use some camera or phones to capture the real world things. That is the low resolution content, right? And then you use some superillusion algorithm to generate the final superillusion images. So actually it's 2 stages. One is the generation and the other is the evaluation. So finally it's the user to evaluate how its quality looks like. So that motivates us to propose another framework called the bidirectional network. It have 2 branches, and how the one branch is to mimic the evaluation, and the other is for this generation. So actually, we have a series of work. So the first work is that we propose this bio-attention network. Is actually we have two branches to mimic the distortion generation and also distortion evaluation, and we have some like the attention just attention replaced from these two branches, and finally we got the quality score. And it's our initial result. And you can see that from the visualization, you can see from this, we propose the bio-attention block, right? So we visualize this feature map before using our block and after using our block. So you can see that after using this bio-attention block, that more attention is focused on this distortion part. So next step, we actually to expand our work. So that is very easy or very straightforward framework. And we also, based on that, we propose another two modules. It's called, so the motivation actually is come from the superillusion itself. So we propose the multi-scale, the deformable convolution that is very widely used in superillusion itself. And also this, we call this sub-information excision convolution. We propose these two different modules to enhance our algorithm. That is another enhancement. And here we showed some results. You can see we have because our algorithm operates on the patch level, it's not the image level. And we showed the different cropped patches and their predicted results compared with the existing models and the ground truth. And you can see that our prediction is more consistent with the ground truth. So next, we want to use our, because we find no full reference superillusion quality metric, and our main goal is to use this metric to guide the superillusion itself. So that's, but our quality metric model is all based on the patch level processing. But if you want to optimize the superillusion itself, it should be based on the full size of this image. And also the algorithm should be efficiently to process, otherwise you cannot integrate into other superillusion algorithm. So based on our previous results, we just need to improve our algorithm to propose this efficiently perceptual bio-attention network. And the mostly is based on we input the whole image and to have this efficient p-band training based on some existing superillusion quality assessment models. And the first work is that we use this as you know, we can serve as a perceptual loss. But now my students also use this to different, except for the final score guide the perceptual loss. We also can use like the feature map to guide the different weights of that superillusion itself. So that is another work. So very interesting results we show here. So we compared, we choose two different superillusion database and also two different state-of-the-art superillusion algorithms. And we use different laws to optimize the superillusion. And we find that if you use structure similarity, actually it got a very high score of the PSNI and SSIM. But if you used our efficient p-band, it got so for the last three columns is superillusion metric itself. So it got very high SFSN and also the last one. And if we find that there are existing, the third method is you combine the structure similarity with our method. That can got you the better trade-off of these results. So to give you another example is that you can see the visualization here. So we have the high resolution reference and one of the superillusion algorithm. And we use the structure similarity and also our model to optimize it. And finally is our model plus structure similarity. And you can see that the structure similarity got very blurry, like the animal fever is very blurry. And also the efficient p-band can go some high sharpening edges, but it's not real. But if you combine the two together, maybe got you some better results. And in our paper, we also have a lot of application study on different ways or different combination, if you can refer to that. And finally is perceptual authenticity assessment for the enhanced media. I think is from my talk to the industry people, I think they mostly care about the authenticity of those AI-driven content. So for this work, we actually built the first of these authenticity data sets that we use the instant 360-degree the T-Tag camera to accurate the real 8K omnidirectional images. And also we generate those images using 4 types of the super resolution algorithms. And you can see that if you look at the first row of this image, that is native is captured by the real camera, and the other 4 is generated by some super resolution algorithm. And you can see that they are maybe not different from each other. If you see the first row, they look very similar. But if we convert them into the frequency domain, like using the FFT or other frequency transformation, and you can see that there exists more different characteristics. So that motivates us to propose the algorithm to help to detect, to classify the different, whether this image is generated by AI or not. So that is our model. I don't want to dig into more detail about the model. Actually, the main idea is the frequency aware of this model, that we use the 360-degree to divide into different viewpoints and use the viewpoints to propose the frequency aware layers. That is our main contribution. And our results is that we compared with different quality-asset models and also the frequent net. So the main result to classify whether this image is generated by the AI algorithm, the AI super resolution algorithm, or it's captured by the real users. And you can see that the very interesting is that if we use the frequent net, even if you input the viewpoint to have a large size of this viewpoint, maybe their algorithm is out of memory, and even our algorithm can be used at 800 times 800, and it still has got very high accuracy. So that is just one of my example to show what the authenticity is very important nowadays. So my main vision for the future is just we are in a new area that we want to transfer from the traditional quality, like the perceptual quality, to the trustworthy media, and how to build a new model that can evaluate. Like I said, the real world is always the AI generated design enhancement, how to apply into the real industry scenario. That is my main idea here. And I think it's time. So I want to finally, that we are now organizing the quality of multimedia experience this year. And I want maybe the final deadline is at the end of this month. I want maybe you can contribute some like 4 papers or short papers, or whether it's demos, and to join us, because it's the first year in the UK. So yes, thank you very much.
Thank you very much. Floor is open for questions. Any questions?
No question?
If you can go a bit on the results that you were showing, you had a lot of results. Yeah. All right. So, what would you say is the best metric for now? Like, if you had a combination of metrics to assess of the ones we use at the moment, what would you suggest? Like, which combination of metrics would be the best to use of what we have now that you think captures better at the moment the enhancement characteristics after super resolution?
Okay, so thank you for your question. I think that is a very open question. That we always want to propose a better algorithm to optimize the super resolution. Even you can see that this result is only show one of the super resolution algorithm.
Yeah.
Even we we test on another super resolution algorithm, maybe it's give you a slightly different result. And for some visualizations, you always want to choose some good visualization results. So that is a very maybe I think in the future, if we can develop like a search algorithm and to how to based on our applications, how to search the best applied algorithm, that is very useful. Yes.
Yeah, no, I can imagine. My guess is here, like especially in the pictures and the images you are showing here, we have a lot of structure, right? So for these images, I'm guessing that the SIM, that's why you're adding it there. That helps a lot. But what about other types of content that is like a bit not as structured? Like if you had like skies, or if you have like water, like more in the medium frequencies. Like, do you think, what would you do there? Would you have like a different kind of approach there?
Yeah, it's also a very good question, because nowadays we also work on those. We find that human vision system is actually they have a slightly trade-off between these different. Like the one is the fidelity, the other is something like naturalness. If you got like a high complexity image, like the texture is very rich, and those image you always got the high naturalness, but not the fidelity. But if you got something like the water or some low complexity, is called complexity, low complexity image, and you always can got some, even if it's blurry, you think it's good, and its fidelity is more important. So nowadays we are conducting some user studies to connect you can see that existing database always has one mean opinion score, and we want to have this like the human vision system is not like one score. Maybe it's fidelity plus naturalness, or some balance between two dimensions.
Yeah.
That is what our currently study.
Yeah, thank you. Yeah, my guess is like you will need like more aspects to encapsulate more aspects. Thank you very much.
Thank you.
I got. Sorry. Sorry, I got another quick question. So, in the generative AI-driven low-level image tasks like restoration or super resolution, the pixel level correspondence always are easily to be corrupted. So, in the quality assessment of those media, do you think that fidelity always still matters? So do you think the fidelity matters more, or the perceptual quality matters more? So that's my question.
You mean which scenarios
For the generative AI-driven algorithms, the pixel level correspondence always
I think that is a good question. It's also determined on the content itself, and not always like you mentioned. If you want to generate a complexity image, or just water or some blurry or some image, it depends on the application error. And even I think about if our application is for generate some artworks, for example, artworks, I think is authenticity is maybe not very important, because they are not authenticity. Some art is very abstract or other things. But if you want to generate a content to apply into the real life, authenticity is very important for our social media. I think it depends on the application, and also the fidelity. From our study, we now conduct some data sets. It's also we think the human, from our algorithm or our study, we think that human brain is something like the trade-off between the fidelity and naturalness, also based on this content.
Thank you very much.
Thank you.